Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So today we are going to deal with traveling salesman problem. And first of all, let us understand what traveling salesman problem is. So as it has been written here, there are number of cities a salesman must visit. He starts from his home city, passes through each city once and only once and return to his home city. So for a salesman, he usually had a starting point which may be his home city. So starting from there, he must visit all the cities and he must visit each city only once, and after completing the tour he must return to the home city or the starting point. So these are the conditions for a traveling salesman problem, and we have in previous lecture also we have seen that the problem can be of symmetric type or asymmetric type. In symmetric type problem, the direction of travel is independent of time, cost or distance. Suppose in this particular matrix the cost is given, so cost from A to B is given as 2, whereas cost from B to A is given as 6. So both the costs are different, that means they depend on certain things, whether it is root or any other criteria. So for this matrix is asymmetric matrix, and if both the values are same, then we can call it a symmetric matrix. Okay, so let us quickly move on to the problem, and the problem says that a salesman wants to visit cities A, B, C, D and E. He does not want to visit any city twice before completing his tour of all the cities and wishes to return to the point of starting journey. Cost of going from one city to another in rupees is shown below. Find the least cost route. So in this problem there are 5 cities it has been given, and the cost from traveling from one city to another is given, and we need to calculate the least cost route. So as we can see here, we can see that there are already 5 zeros here, which represents that the cost of going from city A to city A is 0. Similarly, B to B is 0, C to C is 0 and so on. So we know that the salesman cannot go from one city to the same city as it has been prohibited, and we do not take this value in consideration. So what we will do is we will put a penalty in these spaces. So let us modify this matrix, and now in this particular matrix we have 5 cities and the corresponding cost of travel is given, and cost of traveling to the same city is given as infinity. So we have taken a penalty as infinity so that it will always avoid assigning this cell. Okay, so now we are solving this traveling salesman problem by Hungarian method, and to solve that, first we need to calculate the row minima and column minima. Sorry, first we need to calculate the row minimum or column minimum, or we can say row reduction or column reduction. For that we will select the minimum value in a row, that is for row 1 minimum value is 1, and we will subtract each element of this row by this minimum value. And we are doing this because for assignment we need to have at least 1 0 in each row and in each column. So let us start here, and for the next matrix we can see that in row 1 the minimum value is 1, so 1 is subtracted from each of these elements, so this will remain infinity. 2 minus 1 is 1, 5 minus 1 is 4, 7 minus 1 is 6, and 1 minus 1 is 0. Similarly for row 2 the minimum value is 2, so 6 minus 2 is 4, this will be infinity. This is 6, 3 minus 2 is 1, 8 minus 2 is 6, 2 minus 2 is 0. Similarly, row 3 minimum value is 4, 8 minus 4 is 4, this is 3, infinity, 0 and 3. For row 4 the minimum value is 4, so 12 minus 4 is 8, 0, 2, infinity and 1. For row 5 we have minimum value as 1, so 1 minus 1 will be 0, 2, 1, 7 and infinity. So now we have 0 in each row, but we do not have 0 in each column. So again we need to do column reduction here. For that we will select the minimum value in the column and subtract each element of this column by that particular minimum value. So for column 1, 2, 4 and 5 we can say that the minimum value is 0. So there will be no change in the column values. So let us quickly write here infinity 4, 4, 8, 0, 1, infinity, 3, 0, 2. Then in this particular column 3 the minimum value is 1, so 1 is subtracted from each element from this column. So 4 minus 1 is 3, 1 minus 1 0, infinity minus 1 is infinity, 2 minus 1 is 1, 1 minus 1 is 0, and the remaining two columns will remain as it is because they contain 0. Infinity 7, this is 0, 0, 3, 1 and infinity. So now we have zeros in each row and in each column. Now our next step is to make assignment, and to make assignment first we will try to assign row wise and then column wise. If there is a single 0 in the row we will assign that particular 0, and if there are more than one 0 we will skip that particular row and move on to the next row, and similar thing we will do for column also. So let us start here. For row 1 we can see that we have a single 0 here, so we will assign this 0, and once this is assigned no more assignment can be done in this row and in this column, so this 0 will get crossed out. Now in row 2 we have single assignable 0 is present, so we will assign this 0, and once this 0 is assigned no more assignment can be done in this row and in this column, so this 0 also get crossed out. Moving on to row 3 we have a single 0 here, so we will assign this 0. Now moving on to row 4 we have a single 0, so we will assign this 0. Moving on to row 5 we have single assignable 0, so we can assign this particular 0. So as per this matrix we know that for a 5 cross 5 matrix, if we have 5 assignment our solution is optimal. So this shows an optimal solution for an assignment problem, and we need to check whether this solution is optimal for traveling salesman condition or not. So let us understand here. First of all let us see what are the routes it is traveling. So I am just writing here A, B, C, D, E, A, B, C, D and E. So first we can see that it goes from A to E, so A to E, then E to A, so E to A. So we can see that the salesman is going from one city to another and then coming back to its own city, which is creating or making a subtour, which is not possible for the traveling salesman problem. And let us again see other assignments: B to C, B to C, B to C, C to D, C to D and D to B, D to B. So for this particular assignment we can see that we have two subtours which we will not consider for a traveling salesman problem. So what we will do is we will not consider this problem as an optimal solution and we will try to improve this solution. And how we are going to improve this? So let us again write here the same values: infinity 1, 3, 6, 0, 4, infinity 0, 6, 0, 4, 3, infinity 0, 3, 8, 0, 1, infinity 1, 0, 2, 0, 7, infinity. So now what we can do is we will try to assign the minimum value that occur in this matrix after 0. So because previously we are assigning the value 0, and now we will try to assign the value where we have greater than 0 or the next minimum value in this particular matrix. So we can see that after 0 the next minimum value is 1. So let us start assigning. So in row 1, instead of 0 we will assign the next minimum value 1. So once this has been assigned, no more assignment can be done in this column and in this row. So these two zeros will get crossed out. And now moving on to row 2, we have more than 1 0, so we will skip this. And moving on to row 3, we have a single assignable 0 present here, so we will assign this 0. And once this 0 is assigned, no more assignment can be done in this row and in this column. Now moving on to row 4, we can see that we do not have any assignable 0 present in this column. So what we will do is we will try to assign the next minimum value here. So as we can see here that we have two values, 1 and this one. So we can see by assigning any of them that what will be the output and if it is following the traveling salesman condition or not. So as of now I am taking this one and I am assigning this 1. So once this has been assigned, no more assignment can be done in this row and in this column. So this will get crossed out. Now moving on to row 5, we have two assignable zeros present here. So we will skip this, and now we will try to assign column wise. So column 1 has a single assignable 0. So this will be assigned, and once this is assigned, no more assignment can be done in this row and this column and in this row. So this 0 will get crossed out. Now column 2 is assigned, column 3 has a single assignment 0. So again this will also get assigned, and we can see now that in a 5 cross 5 matrix we have 5 number of assignments, which suggests that we have an optimal assignment. So let us now check whether this assignment follows the traveling salesman problem condition or not. So let us see that A moves from A to B, A to B, and then B to C, B to C, C to D, C to D, and D to E, D to E, and E to A, E to A. So as we can see here that a salesman is visiting all the cities, only one, and returning back to the starting position. So this is the sequence, and the starting position of the salesman can be any of this city. So if it starts from B, it will be C, D, E, A, B, and if it starts from D, D, E, A, B, C, and D again. So this is the format. Now let us calculate that what will be the minimum traveling cost here. So the Z minimum here will be given as Z minimum will be given as, so these values, this will be 2, A to B is 2, plus B to C is 3, plus C to D is 4, plus D to E is 5, and then E to A is 1. So this is total 15, rupees. So as we can see that the minimum value we are getting here is rupees 15, and the salesman is traveling all the city one and only once. So this satisfies the traveling salesman condition. So according to us, according to this problem, this assignment is the optimal assignment to the traveling salesman problem. So if you like the lecture, please share the lecture. Have a nice day. Thank you very much.